The title of this video might be a bit of a mouthful, Ferritic Ion Plasma Nitrocarburising, but it describes the process accurately. So let's break it down and understand what this heat treatment is all about. First, let's start with the term ferritic. Take a basic steel grade from the iron-carbon phase diagram. To keep things simple, we'll ignore other alloying elements for now. This type of steel is primarily ferritic, meaning its crystal structure is body-centered cubic, or BCC. A ferritic steel is relatively soft and ductile. Now, if we want to change those properties, for instance, to increase hardness, we need to alter the steel's structure. One way to do this is through heat treatment. If we heat the steel above the eutectoid temperature, which is around 727 degrees Celsius, it transforms from ferrite, BCC, into austenite, which has a face-centered cubic, or FCC structure. Then, by rapidly cooling, or quenching, we can form martensite, a hard and brittle phase with a body-centered tetragonal, BCT structure. But in ferritic nitrocarburizing, we stay below that eutectoid temperature. That means the steel retains its ferritic structure throughout the process, hence the name. Now let's look at the ion plasma nitrocarburizing part. In our earlier video on plasma nitriding, we discussed how alloying elements affect the surface hardness and case depth. These elements form hard nitrides during the process. But what happens when your steel doesn't contain many strong nitride formers? Nitrogen diffuses into the crystal structure and distorts it, which increases the hardness, but not as much as when it forms nitrides. Nitrocarburizing offers a way to significantly boost surface hardness and wear resistance by promoting a thicker white layer compared to standard nitriding. There are three main differences between ion plasma nitriding and nitrocarburizing. 1. Carbon addition. A small amount of carbon-bearing gas, like CO or hydrocarbons, is added to the plasma atmosphere. This helps form a thicker white compound layer. 2. Temperature. The process runs at a slightly higher temperature than standard nitriding, though still below 727 degrees Celsius to maintain ferritic structure. 3. Time. The treatment time is usually shorter, but still long enough to form an effective white layer. Ferritic ion plasma nitrocarburizing is widely used across industries, from automotive components like gears and shafts, to tools and welding tables, wherever enhanced surface wear resistance is required without altering the core toughness.
Ionitech. Technology, solutions, expertise.